The show starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Okay, hello everybody. Can you guys hear me clearly? Hồ An Lạc said that the song Captain. Okay, actually that this song I karaoke with my friend and I post into my YouTube for memorize. Okay. if I sang that song, everybody will go. So I can. I have no one watch my video today, and I will be very sad. Very sad. Okay. Happy Teacher Day. So you mean in the India now it's a Teacher Day? Because I remember Teacher Days it will happen on 20 of what? November, December, October, right? October, November, December. Okay. Okay, so it's nice to meet you, all of you. Okay, so let's get started. Okay. Have you guys joined the Leetcode today? It's very, very hard, very hard contest for today. You guys can see that. You guys can see that I cannot show the problem 3 here. And go to the discussion. There are a lot of people that dislike disable the admin post. And there are one question against here because question 2 is not easy. Question 2 use sorting and by research. Not easy. Question 3 use dynamic programming. This one use dynamic programming. I cannot show it, but I can show this one by use union find and the get param factors of a number by use few of erratothesis. This is we can see the prime number in ON. So if you guys want to check the solution, can check my post. Yeah, here. I wrote the idea, general idea, then implement for you guys to see. Okay, and time complexity and spy complexity. Yes. Okay. Okay. So let's get started. Today we will continue with the online assessment, mock assessment. Continue with Microsoft because Google I already saw all the problem. Facebook already saw all problem. Amazon is a bit easier. Amazon is a bit easy. Microsoft here is very, very hard. What's your rank today? It's 200. 200 plus. 200 plus. I'm lucky that I can solve the problem for. Yeah, this rank. It's still okay. For the days after today, we have a bi-weekly, right? I can in rank this one still fine. Still fine. Can increase my rank. I believe that my rank will increase after that. Okay. 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 Anyone have something to say? Okay. If not, then let's get started. Okay. So today we have 3 questions. Okay. As like other live stream, I will simulate the interview process by first of all, I will read the problem statement and come with the example to understand the problem clearly. Okay, and then I will have some idea to solve this problem. If I found that this idea can work, I will implement it. And then after I submit my solution, I verify, I recheck my algorithm again, my code again. If I sure it work, I will submit. And then after that, I will tell the time complexity and space complexity. Okay. Okay. So given the root of binary tree here, find the maximum value v for which there exists different node A and B where different absolute value of A and B is v here. Okay, and A is an ancestor of B. Okay, a node A is ancestor of B if either any child of A is equal to B, A is ancestor of B, it means that any child of A is equal to B, or any child of A is ancestor of B. Okay, any child of A here is ancestor of B. So it's there are 2 K, right? The first here is that any child of A, for example, ancestor like this, A like this, and B like this. So the child of A here can become B, right? So A here become ancestor. Or any child of A is the ancestor of B. So for example, B like this, right? A like this, and child of A here, C here, is the ancestor of B. So it means that for example, that we have A and B the same node, right? It cannot happen, right? So it means that A always be the parent or the ancestor of B cannot the same with B. Okay. Because A and B here are 2 different nodes. Given the binary tree, find the maximum values, right? So the absolute value of them is maximum. Okay. So that's the problem statement. Can we tell the answer in comment? Yeah, can you can tell your idea. You can feel free to tell your idea. I will read it. Okay. Okay. First of all, we have this binary tree. So what is the maximum absolute difference between 2 nodes? Okay. So if you have 8 here and 3 here, it will be 5. 3 here and 7 here, 4. 8 here and 1 here will be 7. 10 here and 13 here will be 3. So the maximum absolute difference will be 7. Okay. Because B is 1 here, right? Not 1 here. And the ancestor will be 8 here. Okay. Okay. This is 1 because this is 3 because this is ancestor and this is not B. So the absolute value is 3. Okay. So we can understand the problem requirement, right? So now let's check the constraint. The number of nodes in the tree is in range, so it will be less than 5,000. Okay. 5 multiplied by 10 cubed. Okay. And the value here is less or equal to this one will tell 10 2 power of 5. Okay. Okay, how to solve it? Can we dfs? Okay, from the root we dfs, and then every value here is a positive number. No, don't have the negative number. Okay, so if we dfs, if we keep the maximum, right? If we keep can keep the maximum and minimum, right? We need to keep the maximum and minimum because for the current node here, right? If we keep the maximum so far, so we can have the difference between the current here can treat as the minimum and this is the maximum, so we can get the difference. Or we keep the minimum so far, so this one, the ancestor will become the min number and the current node will be the max number, so we can have the difference. So the general idea is that we dfs from the root to the children, and we keep the maximum so far and minimum so far, and we compare the current node here with the absolute value between them. So we can get the maximum. Okay, the idea is intuitive, right? During the maintenance. Yeah, correct. Okay, so this problem is quite easy for us to remember. Okay, let's just implement it. Dfs root here. Okay, we need to keep the max so far, min so far, and max so far. If the root is none, right? We don't need to care. Otherwise, we will have the global value like answer here. The answer here is 0. Absolute value maximum so far is 0. Okay, and then we just compare root. Compare here min so far. Okay, so min so far. So we take the current value here at the maximum, so we minus by min so far. Okay, and we have our answer here. We max up current our answer, and this one we check root here is the maximum, and we check root here is the minimum, so 2k, right? Okay, and we just dfs left side, and we update the min so far, so it will be min of the current value, root dot value with the min so far. Okay, and max of root dot value with max so far. Okay, do the same with the right subtree. Okay, so finally we just dfs from the root with the min so far, right? So we need to set the min so far here is the maximum, initialized by maximum. Okay, can set any maximum number, or we can set it as a root value also fine. Okay. Okay, so okay, so finally we just return our answer here. Okay. Okay, correct line, right? So let's check our code again. We have our answer here. If none, we don't need to do anything. If then we process the current root by get the maximum between the current answer so far and treat this one as a maximum. Okay, treat this one as a minimum. Okay, and we dfs on the left side, update the min so far and max so far, min so far on the right side. Finally, we just set this one. Okay, it's correct. Okay, the time complexity for this approach is on, because we visited every node one time. Okay, and the byte complexity will be the depth of the stack, which is the height of the tree, height of the tree, the binary tree. Okay. So the first problem seems straightforward. Okay. Okay, I think this easier. Let's move on to the question 2. Okay. Return the lexicographical smallest subsequence of S that contains all the distinct. Can this problem be resolved using the BFS and Q? BFS, right? BFS, we can traverse level by level. Okay, we have this one, we traverse this one, we traverse this one, we traverse this one. Can we just have the BFS, right? We just traverse level by level here, and we keep the maximum so far. We need to keep the maximum by level. So for example, that for this level, right? After you traverse all this level, and you start for example, the when you process this one, right? So you need to make a new min so far and max so far, so it don't affect of the current traverse level here. So after you finish this traverse level and you set back the min so far to the new min so far and max so far to the new max so far. Okay, so this can okay. Okay, return the lexicographical smallest subsequence S that contain all distinct characters of S exactly one. This question is the same with this one. Okay. Return the smallest subsequence that contain all the distinct. So we need to return the subsequence that contain all distinct characters in this. Okay. For example, that we have example 1 here with this one. So the distinct character will be A, B, and C. So the smallest one will be ABC. Okay. For example 2. Okay. So we have the distinct element character like A, B, C, and D. So we have A here. You need to have A here, okay? And A is the smallest here. So we need to have something like B. But if we use B like this, so we will mix the D. So we need to use C here and D here and B here, okay? So we have A, C, D, B. Okay. So we have the length of the string will be less than 1000 here. So we then can use up to n square. S contain only lowercase English letter. Okay. So how to solve this? How to solve it? You have C here. So when we scan, right? When we scan, we need to make sure that we need to have at least one C. So how about currently we mix C and then we add C here. We mix B. We add B here because B haven't existed yet. And A here, we just add A here. And when we mix C here, right? We found that there is a duplicate. Can we remove this one? Can, right? We should remove the existing one if it duplicate. Okay. And mix D, just D here. Mix C here. Mix C here. Mix C here. Mix C here. So we just can remove the existing one. B here. Yeah, if we remove the existing one, we need to make this is the smallest lexicographical. So, okay, when mix C, would C, because we don't have enough we don't have all the distinct character yet. So when we mix B with B, we mix A with A, mix C with C here, right? So we found that this form all the distinct character exactly one already. So we just update our answer so far. This is our answer so far. Okay. And when we mix like D here, no, when we mix D here, so we, so A here, right? B here, right? C here, right? No, C, D, A here, right? And we mix C here. So we can remove C here or keep C here. We can remove C here or keep C here. Okay. So if we remove, we found that the before of it is the smallest. So it's better to remove, right? It's better to remove. So this one become smallest. So it's better to remove. So we make a duplicate. So we consider this one with the previous value. The previous value. Okay. So it still look like that we can remove. Okay. So let's remove, because B here is more than C here. So just remove. We have this one. Okay. And we made D here not existing yet. We add D here. This one form all the distinct characters. So we update our answer so far. When we mix C again, right? We check, should we remove C here? If we remove C here, right? We mix D here. D here not good compared to C here. Right? If we remove this one, it will become D, which is larger compared to current one. So we better skip this one. Better skip C here. Okay. When we B again, should we remove B here? If we move B, right, we can have A here is the smallest than B. So it's fine. It's better to remove B here. So just remove B here. Okay. So we have the new answer here. So we update, we compare and update the current answer so far. When we mix C here, right? So we check the previous of C here is D here is not smaller than C. So we skip C here. Okay. I think we don't need to keep the answer so far. This one is the answer. The final one is the answer, because when we traverse, we already consider the minimum. So this one is the answer. This one is hard. Yeah, quite hard. Okay, we just come from example first to check if we can see any special button. Okay. Okay, so we have some idea. Let's go through this example. Go through this example. So we have B here. So add B. Have C here. Add C. Add A here. Add A here. Okay. So we already formed all the distinct character, right? So now we mix B here. We consider, should we skip B here or keep B here? If we keep B here, right? So we need to remove this one. But this one is greater than this one. So if we remove this one, it will not good, not optimize. So we need to keep B here, okay? And skip B here, okay? Then continue with C here. Okay. So before of C is 8, which is smaller compared to current C. So it's better to remove C here and use the C here. Okay. So we can have the why it's not correct? Let's check again. B here, C here, A here. So if we remove B here, right? So we are currently compare only C, but after that the C here can be removed. So our current our algorithm here is not correct. So we need to consider the A here as well. We can do the linear scan. Linear scan, for example, that's the first. We have this one already, right? When you have a B here, okay, we will we will check if we should keep B here or not by scan from B here up to B. Okay, we scan linear time. Okay, to found if we have the element smaller than B or not. Okay, when we scan, right, we scan B here, we scan from this position up to this position. Okay, so we scan like C here, and we check we have the C after of this. Okay, so we will have the smallest value so far will be C. Okay, and we keep continue scan with A here. Scan with A here, and we update the smallest A. Why? So we need to consider if we can remove C in the future, because we already know that in the future we already have C in the future, so we can remove C here. Okay, so we can have the smallest EA. Okay, I will explain the idea again. Okay, so if I mix B, right, if I mix B here, okay, I will check if I can remove B here or not. Can, right? Because after that in the future it's have B. Okay, so I can achieve C here. So I have a smallest EC. Okay, and I scan with C here. I check if C in the future have C or not. If have, I will can remove C here to achieve A here. Okay, so the smallest EA, which is less than B here. Okay, so let's remove B. Okay, and use this B. Okay, and C here. Okay, I do the same. Okay, C here in the future have C, right? So if I remove, I will achieve the smallest EA. Okay, and I will check with A. If I remove A here, right, in the future there is no A anymore, so there is no or distinct catcher, so I cannot remove A to achieve B. Okay, so I have the smallest EA here. I break. I have the smallest EA, which is less than C here, so it's better to remove C. Okay, so I can solve this problem in n square, which is can. Okay, the idea seems work. Okay, let's implement it. So before this, I need to check. I need to have something to check if in the future have something in the future or not. Have something in the future or not. I will do like in the future or not. Alright, I do like the index so far, the right so far. Okay, so this will have this will be the from a character and index. from a character and index. So I let this one, right? Let's this index here, right index. So let this one and the character and the index I e the rightmost index of C. Okay, the rightmost index of C from index E I here. Okay, the rightmost index of C from index I, from index the rightmost index of C in string from I plus 1 up to n minus 1. Okay. Okay, I have the right index. This is the rightmost index, something like this. Okay, I will define this one. So I will make it like can be a 2D dimension. Okay, first of all, I will have the length of string, here. Okay, and this is the column, right? This is rows, right? So I have how many columns? First of all, I will initialize with -1. Okay, I have this one column, and for this one in range of 26 character. Okay, 26 character because lowercase, right? When we minus with the lowercase character a, we can have the 26. Okay. Let's traverse our string from the reverse order. So right so far of the last index. Right so far we exclude I here. Okay. So the last one will have nothing, so we -1. Okay, and we just traverse from this one, rightmost index from this one, and the catcher here will be s of I here. Okay, this one rightmost index of this one will be rightmost, right? So the character here, so it will be rightmost, right? So it will be maximum of the rightmost index of I plus 1, the index C here, right? For example, that this one, if this one have already, so we just we just with the current here, we are consider the current here. Oh, this is exclude, right? So how about that we check this one is inclusive. How about it if this one is -1? If this one is -1, we check if the one is if the current here, this one is -1, right? Look like that we need to check the before of data. The look like we need to check SE plus 1. SE plus 1. Right? So let's this one is from this one to this one for easier. Okay. So let's this one for easy. Okay. So the rightmost of the current character will be the maximum of the current, right? With the before of that. Okay. So we need to check the SA case as well. Basically less than n. So we can set this one. Okay. Otherwise it will be the first one, right? So we can set this. It will be the okay. We can if it less, then we can compare. We set the later. Otherwise, we will set it to the current. Okay, so we can achieve the remote index so far. Let's bring to check if it works correctly or not. C in enumerate of a string s here. Let's bring I and the remote so far of this one. Not a string remote so far here. For in range here. I need to convert it to index. Okay, this one to convert into index as well. Okay, so I have the B here, right? The remote so far should be 3. Why I put 0 here, which is not correct. I need to find the maximum so far, right? -1. If I access, otherwise will the maximum so far of this one. Why this is not correct? Why this is not correct? I access C here, right? I access C here. So remote so far of C will be index 4, 0, 1, 2, 3, 4. Okay, B here, right? So when I mix the year, this one, I access the. I need to copy as well. I need to copy the previous one. Need to copy the previous one. Need to copy the previous one. Or I think I can do binary shots as well. But I need to copy the previous one. If this one, right? So first of all, I will copy. Let's this one first. Okay, I will copy them. Copy. So copy at the current index here. I need to copy. This is the. I need to copy. So let's swap the position so that I can. This is the row, right? This is the row. So I can copy the whole column. Row. I can copy the whole rows. Okay, let's swap. Swap position. Okay, I already position is correct. Okay, so let's copy the previous one. Like this copy from the previous one. Let's bring not correct. Why? I already copied the previous one. Okay, so the B here, right? So the last mode so far, the right mode so far, we have the index 3 here. Okay, C here, right mode so far we have index 4. Okay, A here, right mode so far we will have no index, so it will be 2. Okay, so B here, right mode so far of B will be 3. Okay, right mode so far of this one will be 4. Okay, seem correct. Okay, so now we continue our algorithm here. Okay, we iterate I and C in number array of our string here. So I here is the index and C here is the value as index I. Okay. Okay. So I just keep keep the current answer so far. Okay, I should check if we should use C or ignore C, right? Okay, so if we use C, we need to check the previous one. Okay, previous one is from J here in range 0 with up to length of the current string here. Okay, -1 because for example this one, right? We need to for example when we have A, B, C, A and we mix B, right? So we just traverse up to C here, right? Okay, if we traverse up to this one, if we remove this one, the previous one now have the previous one. Okay, so look like that we traverse from length of answer here -1. Okay, if we have the before the rightmost so far of it, rightmost so far of the index tray. No, not the index. Rightmost so far of index tray. Yeah, correct. No, we need to keep the original index as well. So our array will store like the character first and the index, or the index is fine, still fine. Array of index in string s. Okay, if the index, right? We have the index inc here. Okay, index and catcher. Okay, the index will be answer of tray here. Okay, the catcher will be s of the index. Okay, if the rightmost so far of the index with the catcher here, we need to exclude this one. We can consider from the for example, if we mix B, right? If we mix B here, we consider that in the future there have B or not. So our index will start from this one plus 1 is fine. This one plus 1 is fine. Okay, so let's use it. This one plus 1. Okay, if it's have the greater one, it's different to -1, right? So it's will have. It will have. Okay, it have the rightmost index. So I just use it. You see here. Okay, you see by remove the C. Oh no, I need to have the smallest catcher initialize with Z. Okay, so if I can remove it, right? Okay, if I can remove it, I will get the smallest catcher by the previous value, by the previous value. Let's copy this example for you guys to easy to see. Okay, so if we found B, right, in the rightmost, right, we can remove B here. So we can have the smallest will be the current here +1. So s of index +1. Okay. So we jump after that. We check if the smallest catcher here should we remove or not by compare it with the no, we need to start from the previous one. So we need to check if catcher here is in S or not. If the duplicate, if it duplicate, we can. So we need to check if our answer here exists B or not by if C in, because we store array of index, right? Let's store two array, array of index and array of catcher. Okay, array of catcher here. Or a set in find a set. So we need to later we need to find the index as well. So let's store, this is the catcher. Okay. So array of catcher in string S. Okay. If C here, right? So for example, B here, right? You need to check if the current one exists B or not. If C here exists in this one, then we will consider to remove or not. Right? So if this one, if it not exist, so we just go straight and abandon, and we can continue. Otherwise, we process this one. Okay. First of all, I check if C here, right? If B here is already existed or not. If not existed, I just abandon C here. This is I abandon the index, right? Index I here. Okay. Then abandon the catcher here, C here. Okay. And I continue. Okay. Otherwise, I check if I should use C or ignore C. So then I will found the index, the index of B here. So I will find the start index will be this one. I just do the linear scanner, still find or binary search. Can we binary search? Yeah, can binary search bisect left catcher here. I check the existing C here, left or right. For example, that I have something like A, B, C, and I need to search B here. I need to search B here. This catcher is not static, so I cannot bisect. So just do the linear scanner. The code now is dirty. Okay, get the. Can we get the start file index? Something like this. This is array of catcher. This is the catcher. Okay. If I here in range of length array here, if array I equal to C, return I, or the y return -1. I will find the answer here with the C here to find the index, start index. Okay, after I have the start index, for example, this one, right? I find B here, and I have the start index in this one. So I will traverse from the start index up to length of this one -1. Okay, and then I find the smallest. Not sure this one. Okay, find the smallest and check with the current, this one. So okay, so if I found A here, right, E less than B here, okay, I just U C, okay, by I remove the previous one by answer here. I remove as index, start index, and answer catcher here. I need to remove the catcher, the current catcher C here, okay, and then I append I use it, right? I use, so I append it, append to the this catcher, like the elastic one, and I append the latest index. Okay, that's all. Okay, finally we just join our answer chair together. Yeah, this can show a monostack, right? I know monostack, but I don't come with that idea. Let's show with this first. The index here. So I need to set this one first. Something wrong. List index must be integer or line, not string. This one. Why? Let's bring index and catcher to check. A here. To convert into index. So we have catcher here. If we have the remote, right? So we just update, remove x not in list, remove x next not in list, answer here like 20, like 63, remove start index here, and this one not in list. Why not in list? This one I return the find the value of this one. Actually this one very dummy. Find the value will be index. Find value here. Find value here. Find value. Okay, we have CAB, which is not correct. So let's check why. Okay, let's bring the current answer so far and current answer chair so far. Okay, first of all, we empty. First one we will take big B, right? B and C and BCA and Y remove B. Yeah, it can remove B because it exists A here, which is smaller than B here. So yeah, so just remove B is correct. Okay, and finally we mix C here, and we have the smaller A. So Y doesn't remove C. Y doesn't remove C. CAB. So we have BCA. First we have BCA, and when we mix B, we remove B here to achieve C A B. When we mix C, why we don't update anymore? When we mix C here, right? So if we remove C, we can achieve A here. Why? So let's debug. Let's debug. Let's debug. Too hard question today. Yeah, I think. Yeah, can you monostack? But monostack is quite hard. But my solution can work in ON square. Okay, let's bring our solution here with this character. Okay, so let's debug why is okay. So first of all, we have this one is correct. This one B C A here, right? And remove B here is correct. Okay, when it mix C currently is C here, right? Okay, so it should remove C. Phi it will be Y. The sort index. No. The sort index. Should find the index. Okay, let's check again. B right, C right, A right, remove B right to achieve C B A right. Currently we mix C here, so we need to keep C. So index is 0 here, so we start from index plus 1. Yeah, we start from index is correct. Let's check again. B C A. Okay, then we continue with current C here. Find the index is 0. Okay, so now we check if we can remove C here or not by we have the catcher index. Okay, and the catcher will be C here. Okay, at index 2. Okay, so we check if the right move value of C exists or not. Exists, right? So we update the symbolic of the 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 one answer plus one. Chủ đất tì nào. Very complex now. S index here. Okay, let's check again. So we have B C A remove. So if you see A B correct. So now we are considering the C here. Okay, find the index in our answer here will be 0. Okay, see here at index 0 of our answer. Okay, we start J here. This is index in the string. Okay, we can achieve the catcher here. So if we can found the right mode, right? So we will update we will update it will be A, right? The index in the string. So this Okay, check again. B, C, A. Okay, consider. Okay, have the rainbow, right? So this one should be B, right? We are remove C, so we achieve A. This one should be A. A, correct? So we have the smallest one will be A, and we consider put A here. If it have the rainbow or not, no, right? We consider we finish. Okay, we have something crash here. We remove start index here. We remove the start index here. Not remove the start index here. Remove the remove the value of start index. Okay. Okay, it's work now. I think I will fail the interview if I did like that. To a lot of bugs. Okay, ABC. Okay. ACDB. Okay, correct. Okay, I think it can work. Okay, I will make the out of index. I need to check this one. I think I need to check this one. 20. Out of index max up here. Why? Why I need out of index? Leetcode. Why I make out of index of this one? Why out of range? If this one still have, right? So I just get it. Why? Or why leaks index out of range? Why leaks index out of range here? Leaks index out of range. I already checked this one. Leaks index out of range. I need to swap. This is need to swap. 26 here. Okay. That's correct. Totally fail for today. Okay, let's consider this example. Check if our algorithm work or not. Okay, I mix B. I add B. Mix C, SC, B. Mix B, right? Check if we should remove B or not. No need to remove, right? Okay, so we have a C again. So no need to remove C. B again, so no need. Okay, no need to remove B. Okay, so we have a C again, so no need to remove C. Okay, we have a A. Okay, have B. Yeah, we can remove B because we have A here is knowledge. Okay, we have A here. Okay, should we remove this A? No need, right? We should remove. So we consider increase consider until A here. So we need to abandon first. Need to abandon first. Okay, so we have the smallest should be big C. Why the smallest one will be A, right? If we remove I here, so let's equal. Why? If less or equal, it will be if this one smallest are equal. If equal, so seems like my algorithm failed. So when I need A here, right? I need to remove A here. Why I need to remove A? If I remove A here, why I need to remove A? Yeah, I remove A here. I can have the new A, which is so for the A here, I check B here. Should I remove A or not? By I consider B only, but this one is small. My algorithm is wrong. My algorithm is wrong. Okay, algorithm is wrong. Okay, so let's jump to question 3 and come back to this question later. Okay, given an array of positive integer array, not necessarily distinct. Okay, return the lexicographical lattice permutation that is smaller than the array that can be made with exactly one swap. A swap exchange the position of two numbers. Okay, if it cannot be done, return the same array. Given the array of positive integer, not necessarily distant, so it can have the duplicate value. Okay, return the lexicographical lattice. So 3 here will be first. That A smaller than okay, lattice but smaller than the current array. That can be made with exactly one swap. A swap exchange the position of two numbers A and J. If cannot be done, return the same array. Okay, I understand the problem now. Collect example 1. I have the input like this. Okay, so I need to dig one swap so that I can achieve the maximum permutation, but it's smaller than the current array. So if I swap 1 here with 2 here, so I can achieve 3, 1 and 2 here, which is largest but smaller than the current array. So this is the answer. Okay, so for example 2, this input here. Why Microsoft problem is so hard? I thought Microsoft is easier compared to Google and Facebook. Why it's hard? Okay, this one I need to find the largest permutation, but smaller than this one. No exist, right? This we already smallest, so no exist. So if cannot be done, return the same array. So if we return the same array. Example 3, input here. Okay, input here. Okay, the answer will be I need to find the largest one but smaller than this one. Mm, this is the I need to find largest one that's smaller than this one, right? So it is smaller than this one. So it will it is smaller than this one, right? So if this one can this one be changed? Can this one change? Can we change this one? If we change this one to we find that the right mode have the greater than this one. So if we change this one will be greater than this one, which is not correct. So we need to keep one here. Okay. For 9 here, should we change for anyone? Yeah, we can change for anyone to become smaller than the current array here. But we need to find the largest. So we can pick the 7 here, right? Can pick the 7 here. Okay. So we can achieve the maximum, but it's less than the current array. So we just swap 9 with the 7, right? Yeah. Okay. Seem quite straightforward. Okay, if this one, right? So if we check this one, if we found the anyone that larger but smaller than this one. So larger that's but smaller than this one. If we use one, right? If we swap one here, this one, right? Less than this one, we can achieve like this. If we use this one and swap with this one, so we can achieve like 1 3 1 3. Okay, which is smaller than this one. But let's come with example 4, example 5. So how about that? It's not 1, but this is 2. This is 2, right? If this is 2, so we need to 3 here, right? So we can swap any one. Like we swap with 2 here. We need to swap the greatest. Swap with greatest value, but less than the current ice here. Greatest. Right? So we choose 2 here to swap. So it will 2 1 3 3. So this one smaller than this one, but greatest, right? How about that? We have 2 2 2. So what have 1 1 here, right? So we need to swap with the first one or the second one, because this one always greater, right? So it's better to swap with the first one. So if the same value, then to the smallest index. Okay. All right. Okay. If the same value, right? So we need to choose the smallest index because this one always greater than this one. So if we swap, so it will become this one good. So if we do like this, we will do linear scan, right? So first of all, we will do linear scan I here. Okay. Then we find the one which is greatest, to find the greatest, the naive solution by brute force linear scan again. So brute force will take n square by we use I, right? I from 0 into -1, and we have the j from I plus 1 into n minus 1 to find the greatest value with less than this one. Okay, so we take the time complexity be n square, which is not good. Can we optimize n square down to n log n or O n? We find decrease sequence from left to from right to left, where the sequence stops. The place we should perform a swap. Okay, let me. Okay, if I do like this, if we take the n square, can we optimize it to be more optimized? By instead we do this one, we can do from the right to the left. If we do the right to the left, so I think we need to draw maybe I maybe I shouldn't show Microsoft problem anymore. It's too hard. So for example, data 3, 1. Example data something like this one, 4, 6, 7 here. Okay, 1 here, right? Go to 9, go to 4, go to 6, go to 7. Okay, 7 here. Okay, so 1 here, 9 here, 4 here, 6 here, 7 here. So if we, so this is decrease, right? Decrease like this. So we are decreasing, right? So if we want to find the one that that's smaller than this one, if it's smaller than this one, so we need to find the maximum. So we just so we just do one. Why we need to do linear scan for I? Just do the first one is enough, right? For example, 3 here. If I cannot find the last, the can I scan I this is not correct, because 3, right? If I find 2 and swap with 3, which is not correct, so it will be 2, 2, 3, 1 here, which is not correct. So I need to find some button to find some button. So for example, that 3, 2, 1, 3, 2, and 1 here. How can I achieve smaller than this one? Just swap 1 and 2, right? So swap 1 and 2. So it should look like that I have the smallest one, I need to find just the one that greater than this one. For example, this one is slow down like this. So to achieve the value which is smaller than this one, so I need to decay the peak. So when I slow this and I make the peak here, so I need to swap this peak. I only swap this peak only, right? No, can I swap 4 here to become 7? If I swap 4 here to become 7, it will greater than this one. So when I slow, right? And I make the I make the larger, I make the increase the peak. I will pick this one to swap with the largest. So now I will swap with 7, right? Correct. And this one, so it's no decrease, right? So we check this one at the need to swap, and when we increase, right? So we just swap 2 with 1. Okay, let's check with another example. So we have 3 1 1 3 3 3 1 1 3. Three one one three here. This is decrease, right? This decrease here, and I make the increase here. So I need to swap with the one which is smaller when I make the increase, right? So when I slow, when I make the increase here, okay, and I will pick this one to swap with the one which is smaller than this one but greater. But in this case, we will do 1 here. So we need to pick the one with the smaller index. So pick 1 here. Okay. So we swap them together to become 1 3 1 3. Okay. So we have the algorithm now. Okay. Bye bye. Bạn Hiên Nguyễn nha. Okay. I think this can work. Okay, let's implement it. Okay, implement it by whichever we have the need to have the best case as well. So 1 1 1 1 5 1 1 and 5. Right? So this decrease. So no increase. So if we don't find any decrease, so it will returns the original array. Okay. So we have that case like this. So how to find the peak slope? Like we I here a n minus 1. Okay, so we need to y I minus 1 greater than 0, right? For the current I here, so we need to compare with the previous of it, array of I minus 1. If it keep decrease, right? If it keep decrease, so it keep decrease. Okay, so we just minus 1. Okay, so if the I here is 0, because For example, this case, if you like this, and I minus 1 like this, if you decrease, right? So I here become this one. I here become this one, and this one also decrease. So I become 0. So if I come to 0, so we return the original array. I become 0, we return the original array. This is case we call is cannot swap. Otherwise, I here is the pick value. So we need to swap with the smallest value. So we need to keep the maximum so far. I max so far. So I max will be this one. I max this one. So if I max but less than the pick one, maybe we do linear scan again. Okay, from this one I do the linear scan again. Linear scan again for j in range I plus 1 with the n. Okay, if I have the j max here, I need to find the maximum so far that less than this one. Minus 1. Okay, if j if value, right, I found the value j here. Okay, which is I need to keep a picker. I pick equal to I. Okay, if I j here, right, is less than array of I pick here. Okay, less than, right? I find less, then I need to update. If the j max equal minus 1, right, I set j max will be j. Otherwise, j max will be or the latest value which is greater compared to j max. I update. Okay, finally I just swap. I pick what the j max. What happened in case that I don't find? In case, yeah, when its own way smaller, so I don't need to check this one. It's always small. So the last one always the last one not always. So if this one or this one, right, this one is greater, then I update. Okay, this one is correct. Nice. What I max here, what so I pick here. Okay, how about that? I don't found anything that yeah, I always found. Okay, let's run. I need to return my array. Okay, 3, 2, 1, which is not correct. Why? Let's bring it come here, not. Yeah, it can come here. Why cannot swap? I pick and j max. So minus 1. So it means that less than this one or this one greater. Update. Minus 1. How about this case? This case this should be in this case this should be 1. Yeah, when it increase, right, it will stop. So in this case, I here is 2. I need to, in this case, I need to treat the I here either okay, so I must minus 1 must be the pick. I must I minus 1 is the pick. Okay, minus 1. Okay, I have 3, 1, 2. 115. Correct. Correct. I think it's correct. Okay, fine. Okay, does anyone have questions? To the I max a negative number. 2, 0, sorry, mixed up. Do you want to solve problem on code for? No, actually that code force problem is quite long. I don't like code force problem. It's too hard, and the problem statement is very long, very hard to understand code force problem. That's why that I don't show the code force problem. Anyone have question for this? So for this problem, I think we need to draw, but in the interview, not sure that the interviewer allow us to draw or not. If we can draw, we can see the pattern. Yeah, Microsoft question is quite hard. Or maybe Leetcode they softer than Google. Okay, so if no one have a question, right, I will continue with the question 2. So for this problem, we just like we draw and we see the pattern by this one is slow, right? So we cannot swap anything. We cannot swap with 4 or 7 with 6 here, because it will greater compared to the original array. So we need to find the increased one, the pick one, and then we swap with the number on the right side, which is smaller than the pick here. Okay, we swap them together. Okay, seems straightforward. Okay, let's move on to the question 2. Seems like my algorithm here not work. My algorithm here not work because like this I can remove this for shorter. This one we expect is BCA. We expect it's BCA. Yeah, expect it's BCA. BCA. So why it doesn't output BCA? Something wrong. This one need to output. I output PCA. I output PCA, but this one I don't output PCA. This one I CAB, but I expect BCA, right? BCA. So I expect BC and A here. Why my algorithm does not work? I have B here, I have B, right? I have C here. I have C here. I have C. Okay. And I mix B here. I check if I should remove B. No, right? If I remove B, I achieve C, so should not remove B. So why remove B? I update something. Symbolic value should not this one. Okay, I need to debug again. So need to debug this string. My x bar is B, C, and A here. Remove this one. Okay, remove this one. Okay, this one can. Okay, so why? Okay, first of all, I have a okay. Let's okay. First of all, I have a B here. Okay, I choose B here. It's C here. Okay, then I mix B. I should not remove B. Right? Correct. I should not remove B. Okay. So when I mix the character A here, okay, I just append. So BCA correct. Then BCA is correct. BCA is correct. BC and A here is correct. So when I mix B, my index here is 0, 1, and A here. So when I mix B, I check B here, B4 have, C here, B4 doesn't have. If it doesn't have, I break. I break. My really bad. Why? Doesn't have I break, which is correct. Why not work? B, C, okay. A, okay. 0, 1, and 4. Okay. When I mix B, okay. If I remove B, I achieve C, which is not less than this one. Okay. And I consider if I remove C, but to remove C, I need to check if C exists. C exists compared to the current index. C exists compared to the current index or not? Compared to the current index. Compared to the current index or not? Compared to the current index or not? Compared to the current index or not? BCA. Hope it will work. ABC, ACDB. Painting of tree set, subject set will show. Really hard problem today. Matrix. No, not matrix. I did n square. Explain again. Đạo, you still here? Okay, explain again. Okay, for example, this for short. Okay. Okay. Expectation is B, C, and A, right? B, C, A is the expectation. Okay, so let's example one first. Example one here. Okay. Explain. Okay, when I mix B, right? B here is not existed yet, so I add B. Mix C, right? C not existed yet, I set add C. A, right? A not existed yet, I add B. A here. Okay. Mix B here. B is already existed. So I'm consider if I should use B here or not. Right? I should use B here or not, right? By I check if I remove B, right? I can achieve C. I have the smallest so far. We initialize with the Z is the largest one. Okay. If I remove B here, I can have C. So the smallest will be, because if I remove B here, right? I can have the right side have the B here, so I can remove B to achieve C. Okay. If I check if I can remove C here, I check if I check if I can remove C here, right? C here, right? Because in the future I have C, so if I remove C here, right? Because I know that in the future I have C, so I know that in the future I will remove C here to achieve A. So I check if I have the smallest. So I scan B here. I have the smallest is C, and I check C here. I have smallest is A. Okay, and I update smallest is A. Okay, so A here is less than B. So it means that if I remove B here, in the future, I can achieve A here, which is less smaller than B. So remove B and new B. Okay. If I mix C here, right? If I mix C here, okay. C here, right? Remove C. I achieve A here, which is smaller than C. So just remove C to achieve C here. So this is the answer. Do you understand? So what I did is that firstly I checked if it have the right most index or not, and if not existed I abandon and continue. Not if it already existed, I check if I should remove UC or ignore C by initialize with the Z1 and find the smallest catcher. If it have the smallest catcher, I just remove it and abandon the new one. So this one we check n square. Not sure if have another better solution for this. B here, C here, A here. Okay. Okay, I think that's all for today. All the problem are medium. Why medium? I already saw this problem before. Use something like this. Oh no, this is the first question. How about the second question? Haven't saw it before. They use something like a stack. Can we use stack to solve it? Yeah, problem are hard, but they claim it as a medium. This one also medium. This one I can achieve in ON, which is correct. But this one they said that we can achieve in ON by using stack. The top vote said that we can use stack to achieve ON. How can in here they try to add the mixing character? We check how to check if adding some new character will not cause the problem. Use big math to check whether you will be able to complete the subsequence if you add the character as something that change. You big math here just like you the hard set for 26. This is just like my solution. Okay, I think that's all for today. Thank you guys for watching. I would like to see you guys on the next live streaming. Thank you. Bye bye.